All right, good evening. Welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here. It's great to have a nice crowd here, even on a cloudy night. I'm going to do what I can to clear out some of those, but wish me luck. Anyway, it's great to see, again, some very familiar faces, but also some new faces. By show of hands, who's here for the first time? All right, good handful. All right. Next question, who here is a member? All right, pretty much the other half. Great. Those people who raise their hands second actually have a particularly important piece of knowledge. Being a Kopernik member gets you into Kopernik and any Friday night and for certain special events. But we're also, the extra benefit that you get with a Kopernik membership is that we belong to what's called the ASTC, Association of Science and Technology Centers. This is a consortium of over 350 other science centers in the country, but also even some are worldwide, that you can use your Kopernik membership to get in for free. Family membership is $75, which is the cheapest thing you're going to find out there. And but you can get into the Roberson Museum in Binghamton. You could get into the Intrepid down in New York City. You could get into the Franklin Institute down in Philly. So if you like this kind of place, this actually ends up being a decent decent thing for you to do, and it does support what we do here. So on our website, we always give you an update of what's going on. So we always list the most recent or the most soon-to-come event. So Destination Neptune is going to be tonight's program. We actually will be running a blood drive. So on Tuesday, May 30th, we will be doing this is, I think, our 7th blood drive here. And so if you're in a position to help out, please make that happen. And what I always do when you do come up here, if it's sunny out, I put a solar filter on one of our scopes, and you can look at the sun safely. And also coming up is Rocket Fest. I know we had some people that have, you saw a number of people sort of lining up out there, and in fact, I think there are probably some Rocket Fest registrants that are in here right now. So on June 3rd, we're going to be launching well over 100 rockets, those Estes rockets. So if you haven't already, you would, when you register, you pick up your rocket either here tonight or tomorrow morning, or tomorrow at noontime at Barnes & Noble, and build it at home. And then you come up on June 3rd during your launch window, and we'll check it out, make sure that it's ready to go. We'll install the engine and the parachute, and you get to hit the button that launches it 500 to 1,000 feet, depending on what power engine you put in there. So it's always a lot of fun. And so if you haven't built a rocket, this is definitely a good time to check that out. We also do a pretty extensive summer camp program. And if you go here to our classes and public classes, summer camps, we have summer camps that span everything from rising second graders through high school. I will say, though, that most of the elementary schools programs are pretty much all filled up, but we do have a number of programs that still have some openings, some rocks and minerals, chemically organic art. This is both sort of a STEAM kind of a thing where you can actually extract pigment from various minerals as well as plants, and then you get to make some paint and then actually make some art. We have another one called Introduction to Astronomy, and the teacher is a physics teacher here in Vestal, really an outstanding. He's actually spoken here a couple of times, and so if you've got a high school student that's has some interest in astronomy, you definitely want to check this one out. This is Return to the Edge of Space Camp is actually one that I run, and it is. The students will put a payload together of some GoPro cameras, some ham radio tracking beacons, some experiments in general. We then launch it on a weather balloon that starts out at, we put a bunch of helium in there. The balloon may be about 5 feet in diameter. It then, over the next 2.5, 3 hours, it rises up to over 100,000 feet, over 20 miles high. And then the pressure at that point explodes the balloon. By that point, the balloon started out as 5 feet in diameter. By the time it gets to 100,000 feet, it's over 30 feet in diameter. It's trying to equilibrate the pressure inside and outside. And then as it drops down, we have a parachute, where again we're tracking it with the ham radio beacon, and then we send the students out to go and collect the package, most likely in a tree. And although I have to say we've been very fortunate that only once did we have to employ the services of an arborist. She had to actually climb up 80 feet to get our payload. It was real interesting to watch that. So anyway, those are some of the summer camps we have coming on. But every Friday night, we always do a public program from March to mid-December, and it's an opportunity to do sort of lifelong learning. It's great to see, again, students here, but it's also great to see people with various degrees of gray hair, and I'll include myself in that. Lifelong learning is really something that keeps the mind sharp, and quite frankly, when I program these Friday night programs, a lot of them are just things that I'm personally interested in knowing about, and we've had some really interesting opportunities. We actually had a professor from Binghamton University talk about the physics of music. Why does a violin, an oboe, and a trumpet all sound different playing the same note? So we talked about the physics behind that. But anyway, so tonight's program is going to be about Neptune. Next week's program is actually going to be about the summer skies. Jeremy Carty is our live stream astronomer. And I'll talk about our live stream in a moment. And so he'll talk about what's coming up in the next few months. So, but speaking of live stream, so back in 2020, we were doing our Friday night programs, and then in March of 2020, we had to shut down because of COVID. And he said, all right, fine, we'll just wait a couple of weeks for this thing to blow over. And well, that didn't quite pan out that way. And so it got to be about May, and we thought, let's do something. We have all these speakers lined up. So we actually had them Zoom into our facility here. We then turned it back around and put it out on our YouTube channel. We now have over 13,000 people on our YouTube channel. So not only to look at our Friday night programs, but also what have been very popular have been observing sessions. Actually, about a year ago, there was a lunar eclipse, if you recall, in May. And during that particular lunar eclipse, we were live streaming that session, and at one point we had over 25,000 people watching simultaneously on our YouTube channel. So it was also great about it. Not only do you get to watch it live, but it stays on our YouTube channel. So if you missed a program, you can always go back and watch it on the YouTube channel. So actually, if you go to our YouTube channel, is simply Kopernik Observatory, and so you can look at what were live programs. So last week we had, trying to think here, 20,000 Leagues Over an Alien Sea. We've got Roberts tonight. Actually, a couple weeks ago we did the historic Marconi Tower. Down in Binghamton, there's a tower that Marconi, the inventor of radio, had installed for an experiment. But anyway, so you can go to our YouTube channel on that. But let's dive into the program tonight. Robert Seegers is one of our educators here, and has actually been offering a deeper look into a number of the planets in our solar system, and tonight happens to be dealing with Neptune. So, Robert, we'll turn it over to you. Yeah. And you turn on your. Oh yeah. That's actually let's.
Okay.
Get this back up. It's gonna. Yeah. So let's see. Yes, let's see. Can you close your jacket, your shirt, because it's gonna.
Oh yeah. Can you put it up here?
Maybe. Let's try that.
How's that? Right. Yeah.
All right.
That should
Got
work.
it. All right.
All right. So where's my remote? Thanks.
There you go.
Okay. Alrighty. Well, thanks for coming here. My name is Robert Olaf Seegers, and my favorite topic has got to be the outer solar system. And the last few programs I've done have been like on Pluto or dwarf planets, and today's pretty much also in the outer solar system. And basically, my interest on our topic today came from a book I got a hold of. It's called the Neptune Files, and it's all about the discovery of Neptune. And it was like really exciting. It was a race, and it's actually the first planet that was discovered with mathematics. They didn't see it, but they knew it had to be there somewhere, and it was a pretty exciting story behind it. So it's called the Neptune Files by Tom Standage, and I strongly recommend it. It was I'm not a fast reader. This is probably one of the quickest books for me in a long time. So probably helps that I'm interested in the topic. All right. Well, so our story begins basically with the discovery of our seventh planet, Uranus, discovered by William Herschel back in 1781, and he actually discovered it accidentally. He was pretty much looking for comets. Him and his sister, and they thought at first they had found another comet, and it turned out to be the planet Uranus. And this guy was a freelancer. Like most of the astronomers of the day had projects they had to work on. It was mostly cataloging stars and so forth. So he could kind of do his own thing. And not only that, he made his own telescopes. This guy started out by he was a composer. He started out converting his oboes into telescopes, which is pretty cool. And then he got a little bit more advanced. But anyway, it's an amazing story. So anyway, so everything's fine. We have our seventh planet, and of course, the astronomers were tracking it. They wanted to see where it was at certain times, and after a while, things didn't add up. It wasn't like where it was supposed to be in its orbit around the sun. And in this diagram here, you can see when it was first discovered, it was actually away from this hypothesized eighth planet later on, and they noticed that it was actually running fast. And then all of a sudden, Uranus started running slower. So they knew something had to be out there. And we'll come back to some more of these dates here in a few moments. So when it was first discovered, it wasn't, it was far enough away from Neptune. It didn't instantly, cause any ruckus. And here we can look at another diagram of this, and you can see by the time we get to 1820, now Neptune is actually behind Uranus. So this eighth planet that they're looking for is behind. So then you can just see how they're closer to each other. So as it gets closer to, because Uranus goes faster than Neptune, as it gets closer to Neptune, it actually picks up because Neptune's gravity is making it go faster. And then after it passes Neptune, then Neptune's gravity slows Uranus down. So that's what was going on. So this young English astronomer, John Couch Adams, this was definitely obsessing him. Okay, this guy was known for fun, taking like math problems like with decimals and going to like 200 places to the right, because he liked to do that. So anyway, he was obsessed, and he knew there had to be something out there. So he formally announces to his peers that, I am going to start looking for an eighth planet out there, and that's about 1841. And he actually accurately predicts its location during the summer of 1846. Okay, we'll get back to that in a moment. So here he tells his peers, okay, and they were both him and these guys here, George Airy and James Chalice, were Cambridge men. Okay, and George Airy was the astronomer royal. In other words, he was the head astronomer of Britain. and he kind of was the overseer. And James Chalice ran the observatory in Cambridge. And it's funny, these two guys, you don't really hear that much about them, but they contributed a lot. So there's tons of career highlights between the both of them. Although you'll see here, one of them is not going to be remembered for the best thing here shortly. But anyway, so George Airy isn't so interested in what John Couch Adams has to say. He's like, okay, well, I'd rather look for other stuff. And then somewhere along the line, in the summer of 1846, he corresponds with a French mathematician named Leverrier. And all of a sudden, George Airy is very interested in what John Couch Adams has to offer. So he orders James Chalice to start looking for this hypothesized 8th planet. So here we go. So here he is, Urbain Leverrier, French astronomer, mathematician, and he also later on he actually published all the planets, like all the rotations and so forth. Very extensive catalog started in 1858, and he even went on. He thought there was a planet between Mercury and the Sun, which for a couple years was in some of the astronomy books was called Vulcan, but it was never confirmed, and it was a short-lived thing. But anyway, this guy was very intense, and with his personality, he was, even though he was a brilliant mathematician, for him, 2 + 2 = 22. When he wanted something, he got it. John Couch Adams, on the other hand, was very laid back. He didn't want to pester people. He didn't want to be a nuisance. So that's going to play a role in what happens next. And all right, so like you said, Urbain Leverrier, he also has been calculating now this possible 8th planet. And he started later than John Couch Adams. I think actually 1845, maybe he started early 1846. And also the astronomers in his country, France, they weren't that interested either. But like I said, this guy did not let up. So he contacted the Berlin Observatory, and the guy in charge of it was this guy named Encke, who also was not really interested in it at all. But he had this guy, Johann Galle, who was the main telescope guy, and an up-and-coming kind of student, this guy, Heinrich de Arrest. Now what happens is, so Adams is trying to get Chalice to basically find his planet. And we'll get to what happens there in a second, but they didn't find it. Okay, now what happens, Leverrier contacts Encke. Encke's not interested, so he contacts Galle, and Galle is super excited about it. And on the night of September 23rd, Galle asks Encke if he could please look for this hypothesized planet. And Encke's going to a party. He goes, why not? Have fun, knock yourself out. So Galle and de Arrest are in the observatory, and they're about to give up because they haven't found anything yet. And then de Arrest remembers that his boss has been collecting the latest catalog of stars, although the most advanced at the time catalog of stars. And he goes, why don't we take a look at these catalogs? So he goes in Encke's cabinets, pulls out the latest star catalogs, which aren't even complete yet, but by chance, the area of space where Neptune was going to be was in front of Aquarius. They actually had that latest edition ready to go. So they end up finding it. They see this star with it. Obviously, it looks like it's moving, and with the stars in the background, and this very, very pale blue disk, and they're super excited, and they go get the guy the boss from his party. He comes running out too, and the next day they confirm it, and sure enough, they have found the 8th planet. They have found Neptune, all through mathematics. So Neptune's its official discovery is listed as September 23rd, 1846. Right after that, I should say too, within 17 days after Neptune's discovery, William Lassell, who was a British beer merchant and astronomer, and I guess he paid for his telescopes with his beer sales. So anyway, he discovers Neptune's giant moon Triton just 17 days after Neptune's discovery. We'll get to Triton later on here. So back to the how this all played out. So you can see, let's see closer here. You can see. Let's see if this is a little laser on it. Oops, sorry, I just hit the wrong button here. Here we go. Anyway, you can see how Uranus is about to lap Neptune here. Like 1800, it gets closer. The 1820s, it's like around its closest point, and you can see how the gravity of Neptune first accelerates Uranus early in the 19th century, and then starts pulling it back after Uranus passes it. Now, the reason why I'm showing this slide again, you can see the two predicted paths that both Leverrier and Adams had figured where this planet would be. And it's amazing, Leverrier's was only 1 degree off. Adams was only 2. And so why didn't Adams find it first? Well, because Challis actually didn't realize it, but he had discovered it on August 8th and August 12th of that year, of 1846. Didn't realize that that was, in fact, the planet. He missed it, basically. So it's something he regretted for the rest of his life. But anyway, so it caused a big controversy because Leverrier, of course, it's announced that Leverrier has found the planet. And as a result, then all of a sudden Adams says, "Well, I found it too," and there was a big brouhaha in Europe about who was the official discoverer. All kinds of papers and correspondences were brought together. Adams himself was pretty gracious. He said, "Look, this guy actually deserves credit. He found it." But the other guys, Airy and someone else who I'll get to in a second, said, "Hey, look, we found it too," and we'll get to the resolution of that momentarily. Another thing that was interesting too about that, you probably noticed in the last one, you can see that the orbits predicted by Leverrier and Adams of Neptune are farther away than actually where Neptune's orbit is. And as a result, they thought Neptune was going to be more massive because of the pull it was having on Uranus. But as it turned out, it just was located closer than they thought. And how they thought the planets, as far as lined up distance-wise, was something called the Titius-Bode law. And there was a mathematical formula they had for pretty much where all the planets laid out, where all their orbits were laid out. And back in 1800, this was very interesting because astronomers were trying to figure out why there wasn't a planet between Mars and Jupiter. And it was a pretty big deal. And in fact, they set up something called the Celestial Police. That's how bent they were on finding this mysterious planet. And in 1801, on New Year's Day, they found Ceres, which turned out to be the largest member of our asteroid belt, actually a dwarf planet now. So that became, for a while, that was our 5th planet. But then right after they found Ceres, they found Pallas, then Vesta and Juno and all the rest. And they realized that it wasn't actually a planet. Maybe a planet was supposed to be there, didn't form, or Jupiter's gravity blew it apart, whatever. But that at least explains where it is, because it's the same predicted distance away from the sun as the Titius-Bode law would have. So the other ones are pretty close. You see Saturn is just a little off, a little less than Uranus is just a tiny bit less, but Neptune is significantly less. So that's why they thought it was going to be a little farther away. Okay, so the next guy, John Herschel. This is actually the son of William Herschel, the guy that discovered Uranus. And this guy was pretty amazing. He basically, not only was he an astronomer, he was like a botanist, he was a photographer. He actually invented the blueprint. He also invented the Herschel wedge, which we use when we do our solar observing here at the observatory. So this guy was actually did a lot. He also discovered some of the moons of Saturn and Uranus. And it turned out, he even didn't realize it, but he had also discovered Neptune. He didn't know it, so we call the word pre-covered. Neptune on July 14th of 1830. He just thought it was an aberration in the stars. And anyway, but the guy was actually a great politician. He kind of ironed everything out with his controversy. He basically said, well, we should give them both credit for it. In no way did he ever diminish the other guy finding it first. He also, pointed out the guys that actually found it in the Berlin Observatory. Of course, they were the first ones to see the planet. He made sure they got all the credit they deserved too. And oddly enough, this guy had a party in his house a year later on his grounds, and all these people came, and they were all happy. So he did something right as far as bringing people together. So to this day, there's still controversy about who actually should get credit for it. And here's some other pre-coveries. One of the most interesting is Galileo. He unknowingly discovered Neptune on January 28, 1613. This might be a fun thing to look at on our Stellarium program, go back in time. So what happened was, unfortunately for Galileo, Neptune was actually in what they call retrograde motion. In other words, the Earth is past, in the inside, and it looks like Neptune is like staying still or going backwards. So he didn't actually probably see it move. The strange thing, though, on his diaries or whatever, his notes, he circled it. Why he did, we'll never know. But it's kind of interesting. So Galileo was actually the first person that actually saw it, although he didn't know it. Another French astronomer, Michel Lalande, also saw it twice. He saw it in May of 1795, but he thought it was just a star, then he thought it was a mistake. The first one was a mistake, and he thought the second viewing was a star. So he also never realized that he discovered Neptune. And pretty much, you don't hear much more about Neptune until 1949. The Gerard Kuiper, obviously brilliant astronomer, discovers Neptune's one of its outermost moons called Nereid, one of its largest ones, actually Nereid, discovers it in 1949, probably because it's got a very eccentric, very long orbit. It takes 360 Earth days for Nereid to make one revolution around Neptune. So he finds that. I like this picture because it's at the Yerkes Observatory in Williams Bay, Wisconsin, on Lake Geneva. And my daughter and I go there frequently, and we actually were in that library, so it was kind of a fun picture to find. He was actually there from the 20s through the 40s, and of course this guy also, he hypothesized the Kuiper Belt, which was named after him. He didn't call it that, but he felt there was a belt of a range of icy bodies beyond Neptune. I also went on to basically discover other moons of other planets, and knew that the surface of the moon, before the astronauts got there, he knew the surface would be like walking on, kind of crunchy snow. So this guy pretty much brilliant. So that's unfortunately the best picture of Nereid we have from the Voyager 2 spacecraft, which actually visited there in 1989, which we'll get to very shortly. Okay. So here's an artist's impression of what Nereid might look like, and you can see Neptune's pretty far from it. So the Voyager spacecraft encounters Neptune in 1989. It's like flyby, and it's actually had previously gone by Jupiter, Saturn, Uranus, and Neptune, then before it got to Neptune. So this was its last stop, although it's still going. So, and you can see this amazing, very blue, very swirling atmosphere. The blue is from all the methane that's reflecting back at us. It reflects the blue light. A lot of storms on Neptune. The winds are like 1,500 miles per hour on these storms. Here's a close-up of what was called the Great Dark Spot, where the Voyager saw. It's as big as the Earth, so pretty huge. I can see some clouds. And of course, Neptune had rings. Now, they thought they saw them like in the early 80s, but basically didn't get confirmed until the Voyager went by there. And there's actually like 5 or 6 main rings. And the funny thing, the rings, if you look at the names of the rings, do those names look familiar? Adams, Lassell, Leverrier, and Galley. They're just the people we were just talking about. So at least they got to kind of live in harmony here around Neptune. So kind of interesting. Now, Neptune has got 14 moons. Only one is big. Giant moon is Triton, which we'll get to. Proteus is the second largest moon of Neptune. It's about 230 miles across in diameter. Nereid, which we just saw, Nereid is the third largest, and that's about 211 miles in diameter. And pretty much Triton's the only spherical one, although both Proteus and Nereid are very close to the limit where they kind of can come around size-wise. Let's see here. Okay. And speaking of Triton here, Triton is Neptune's giant moon. It's volcanically active. Those smudges you see are from geysers that go off. There's also ice underneath, too, so the geysers actually are ice, too. There's nitrogen. Nitrogen, of course, freezes at minus 340 degrees. That's about the temperature of this giant moon. And when that little bit of sunlight it gets does heat things up, and it actually causes these geysers to shoot off. And there's a thin nitrogen atmosphere around this moon too. Also, it's unique that it orbits Neptune backwards, like in retrograde motion, which leads most astronomers are thinking that maybe Triton was sort of more like Pluto, a larger version of Pluto at that. And maybe it just got captured by Neptune's gravity, like a dwarf planet that got captured. So it's because it's very unusual. All right. Oh, I forgot this one. This is the fourth largest moon, 110 miles across. This is one of the inner moons of Neptune, in with the rings. Hold over, so back to Triton. So anyway, Triton looks a lot like a cantaloupe, actually. And look at it, the surface is amazing. It's not heavily cratered at all, and that tells us that things are going on geologically, that the surface is being, basically having it filled in, so to speak. When an object heads to our moon or to Mercury or something like that, there's nothing there to stop it, so it impacts it. The same would be true for this because the atmosphere isn't that strong. But as a result of the geological process that's going on, it fills in. There's like ice flows, lava flows, etc. So here's a closer look at it. All these are from Voyager 2. Voyager 2 is the only spacecraft that has actually visited Neptune, although they're talking about getting another one here in the near future. Again, you see the smoothness. Interesting, like tracks there. Icy surface. This one, I was trying to fit this in on the screen. This shows you where the Voyager spacecrafts are now. They're like beyond Voyager 1 is actually beyond the heliosphere, so it's beyond the influence of the sun. But Voyager 2 is not far behind, along with the 2 Pioneer spacecrafts. The Pioneer spacecrafts, though, we're no longer we're not in communication with them anymore. They were older, but they're out there somewhere. But we do still get signals from Voyager 1 and Voyager 2. No cameras, but just signals from them, so we know where they are. So we also have the Hubble telescope that's taken images of Neptune. And this is pretty good, a little not quite as crisp as the Voyager ones we saw, but still pretty neat. And there's something missing in this picture. The great dark spot. Unlike the great spot of Jupiter, the red spot, which has been going on since since the very first telescopes ever saw it in the 1600s, the great dark spot actually disappeared. So there are other little ones that have formed since, so it doesn't have the longevity that the ones on Jupiter. Here's different clouds. This was taken back in 1995. And the false color is just that's used like it's from different wavelengths, just to kind of just contrast different elements in the image. And finally, these just came in recently. The James Webb Telescope has turned its attention towards our solar system, and you can see the rings are definitely pretty apparent in this. This is pretty cool. Here's another view there. Here you see the different moons. Okay, so any questions at all on Neptune or its discovery? Question there?
How do you determine latitude and longitude lines for Neptune and gas giants?
Okay, let me get a little closer. Yeah.
How do you determine longitude lines for Neptune and other gas giants?
Could you repeat the question?
Oh, sorry. Yeah, good. He wants to.
No,
Me. Oh, right. Sorry. Yeah. How do we determine the longitude and latitude lines of Neptune, or for that matter, any other planet in our solar system? And it's pretty much the same way. I mean, Mars is the one we know the most about, and we have all kinds of detailed with Mars's surface. But with Neptune, because it's a gas giant, there really are no features, but there still would be a grid. I mean, there's the North Pole and the South Pole, and an equator, basically, and you would just do the same type of math, for how many degrees above the equator, below it, until you got to the poles. So, but that's a really good question. Yeah. So, any other questions at all? Or?
I'm going to bring my microphone here. We'll go here, and then we'll go back.
So, even though their atmospheres are both made out of methane, how come Uranus and Neptune are different colors?
It has to do with Uranus has a sort of, what's the word? Kind of I want to use the word spongier. It has to do with the, it's got this thing called an electric glow. It's the way the atoms or whatever are suspended above the atmosphere. It doesn't, I guess, do as good of a job as, I guess, Neptune kind of is more energetic. That's part of it. Neptune has more energy, and I think that's probably maybe the best way to describe. That's a good question. We can look that up afterward, but that's all I know as far as to do with the energy of the planet as the difference in the color. So,
I have a question back here.
Rob, for Neptune and its moons, we're always talking about Neptune as a gas giant. Does Neptune have any solidity to it at all? And what about the moons? Are the moons solid material? Do we know that for a fact? And if so, as far as the moons themselves, do they have any atmospheres at all?
The only moon that we would think would have an atmosphere is Triton, which it does. It does have a thin nitrogen atmosphere. The other moons seem to they're very, very, unlike Triton, which is very reflective. I think it reflects like 75 to 80% of the light it gets. The other moons are very, very dark. So the same material, I think the rings are made of the same material. At least a few of those moons might actually be the shepherd moons, like in the case of Saturn, with some of Saturn's moons. Let's see what else. You asked another question. I'm sorry. What was the other one?
Well, I guess the main thrust of the question would be solidity.
Right.
Solidity
Of all of them.
of all of the
Are
the
any
moons.
of them solid?
Yeah, well, there is a solid metallic, like a metallic ocean in the core on the inside. A lot of it's gas, but Neptune actually, other than next to Jupiter, Neptune is the second most has the second most amount of gravity of all the planets. Earth is actually third. So yeah, so the solid part is a lot smaller than proportionally than the gaseous atmosphere and so forth. Yeah, supposedly it rains diamonds in Neptune's atmosphere too. So, yeah.
Any other questions here? Oh, we got one.
Yeah, you said they're talking about sending a spacecraft. Is the idea that that spacecraft would orbit and stay there for a while?
Yes, and I think probably Triton would be one of the main objectives for sure. Yeah, probably there's a lot, and actually because of Triton and because of Pluto, we're very interested now in Uranus's moons as well. They think that there's besides like Triton, they believe has an ocean underneath it, and they think now that some of Uranus's larger moons also would have an ocean underneath it. So they're trying to either figure out a way to go to one or both of them. But again, this is because we're finding, of course, there's Saturn. We have Enceladus with an ocean below it. And Jupiter, we have Europa. So the more water worlds we're finding in our solar system, I think it's kind of making us think even farther out. Before I forget, too, one thing I forgot. I lost some of my slides here. Another important thing about Neptune is also that it actually regulates a lot of those Kuiper belt objects beyond it. Like Pluto, for example, goes around the sun twice for every 3 times Neptune does, exactly. Other dwarf planets like Haumea is another one, goes around 7 times for every 12 times Neptune goes around. So a lot of these are in a resonance, as we call it, in a resonance with Neptune. So Neptune is a very, very important role there in our solar system with the outer solar system. So I meant to say that earlier, sorry.
All right, any other questions? Oh, another one here.
The farther you get down closer to Neptune's core, does it gradually change from gas, liquid, or solid, or gradually change? Or does it gas and then a barrier that's like a few feet or so, and then liquid, and then another, and it's solid?
Well, that's a great question, and that's probably why they want to send another spacecraft there. This is all hypothesized, but they believe there's a metallic ocean around Neptune's core. So think of a metal ocean. That's but that's what they think it is, and that's the buffer between the atmosphere and the core. So, great question. Thank you.
Yeah, I guess it's one of those things that, being earthbound for the most part, we really need to send instruments much closer to. It's amazing that we know as much as we do about these planets, but I think it's when we start sending missions, to really explore it more deeply, then that's where we can really answer these questions more accurately, and it'll probably pose more questions than they answer. Any other questions here? Oh, we got another one here.
So on that image of Triton, so on the bottom it looked all rocky and stuff, but as it got up it looked more wavy.
Yeah, let's see if we can go back to one of those. Let's see here. Let's see here. It's pretty close to here. That one there, or was that one, or was it another one?
Well, it's in this one too.
Here, is that one? Yeah. Well, I think it's maybe certain parts of the moon are actually experience more of the activity. I think that those smudges that you see, those black areas, are actually plumes, that have shooting out. But like I say, there's I guess there's just, it's constantly recoding itself because of its geological activity, so it's smoothing the surface out. So, did that answer your question, or?
I mean, maybe it's just because of the lighting or something, but doesn't at the bottom, it's all white, but with the black areas, but as you go up,
Yeah.
it's all a little wavy looking, and there's that green smudge.
Well, yeah, you mean up here?
Yeah.
Yeah, that's probably the lighting. I'm sure has a lot to do with it. Although there isn't the sky around Triton. There is an atmosphere, just like Pluto. Pluto actually has a blue sky. Triton does too. So that bluish is part of the atmosphere. So that's probably part of what you're seeing. But again, we have the other lights here too. It's hard to say for sure. But yeah.
All right. Let's see here. I don't know if we had any. We had a number of people actually looking on the live stream. We had our frequent flyer from Adelaide, Australia. We have somebody also from Manila watching, as well as Toronto, and we do have a question. All right, let's see here. Okay, when is the best time to launch a future craft to Neptune to take advantage of the alignment of the planets for gravity assists?
Yeah, so I have to check that out. But I know. There's, I've been reading about that. There's actually a dwarf planet way out there called Sedna. That's like the farthest known one, and it's going to get to its closest point to us, I think, in like the year 2071. So they would have to, the way things line up, they say they have to get it launched like by like 2030. So I mean that they definitely calculate that. Of course, you get gravitational assist from Jupiter. That's very important, and so forth. So I guess we'd have to look that up. I've never checked that. I do know Uranus might be a little bit more favorable, which is why they're maybe leaning towards that mission instead of going to Neptune. But yeah, that's super important. Yeah.
Yeah, it's interesting. I guess the a couple of weeks ago, there was they launched a mission to Jupiter called the JUICE mission, and I believe they're doing a gravity assist where they're going like to to Venus, to Earth, so back to Venus and then back out again to really do that gravity assist to really increase the speed. It's mind-boggling how they figure that out. So I think again trying to get out to Neptune. Actually, for those that may or not have seen them on the way up here, did you see the planet signs up on as you were coming up the street? So those signs are actually spaced with their relative distance from the sun. So when you come up here into the parking lot at Kopernik, the sun is right there. Actually, that's what Kopernik is famous for, making the heliocentric model of our solar system. So you start here at Kopernik, at the sun at the entrance of our driveway. You go 130 feet away, and then you hit Mercury. Another 130 feet away, you hit Venus. 1.8 miles away is Neptune. That's at the base of the hill.
East or west?
That's if it's going north, so northeast. Yeah, it's going when you come out the driveway. Take a right, and if you were coming up the big long hill, that's somehow we seem to have lost Saturn. Saturn is missing. We need to find it again. But anyway, so when you to get a general sense of how those planets are laid out, again, Neptune is way out there.
It is, and I just looking now, and it'd be interesting to see how this is going to work out. But there's something called the Neptune Odyssey that's on the shelf for NASA, and it's going to leave in 2033 and arrive at Neptune in 2049. So, I guess because if you want to orbit the place, you've got to
16 years just to get there.
Yeah, probably because they're going to go in orbit around.
Right.
I think flyby, of course, it goes faster, but. So that Neptune Odyssey. So we'll certainly keep that in mind. So,
All right. Well, in the absence of any other questions, I know Robert, if you want, something else pops into your head, Robert will.
The diameter, by the way, the diameter of Triton is about 1,700 miles, so it's larger than Pluto, which is like 1,400 or something. And Neptune itself is about 30,600 miles across, too. Give you an idea how giant it is. So.
As opposed to our 8,000 here on Earth. Yeah. So, especially for those people who are new to Kopernik, we have a rule that you don't get to leave Kopernik until you look through a telescope. However, tonight is not going to be your night. So if you paid to get in, on your way out, you can Ben, one of our interns there, can give you a card to come back on another night that's maybe a little more favorable. We will, however, again, especially for those that are new to Kopernik, we'd be happy to give you a tour of our telescopes. We we can show you a couple, 2 or 3 of our permanent telescopes, and including the one, our biggest one, our 20-inch reflecting telescope, which is what we use to take almost all of our astro images. So anyway, it's great to see you all here tonight. Thank you again for coming up, and I promise, I'm told that we will have an actual parking lot next Friday. So.